Language has maybe like 20, $30 billion going towards it, and like images has like sub 1 billion. Just feels like we're so far away in images compared to language. We were only looking for like maybe like a 2x leap or something like that, and it ended up being like a 4x leap. For images, there's not a lot of literature about like someone trying to scale something to, 100 billion parameters. So it's kind of this new frontier, actually. We don't know. We don't know how far it can go. We have to try. We have to test.
Hi, I'm Brett Gibson, and welcome to HiBit, a new podcast where we do deep dives on the art of problem solving with engineers and technical experts from our community of early stage startups.
In today's episode, we're sitting down with Suhail Doshi. Suhail is a self-taught programmer and multi-time entrepreneur who previously founded Mixpanel and Mighty Computing. He's now the founder of Playground, an AI image generator and editor. Playground recently launched its latest and greatest model, which you can check out at playground.com.
The details of engineering problems fascinate me, but I'm just as interested in how the best engineers I know think, how they zoom in on which details matter the most, and then use that focus to navigate to elegant solutions. Join me on this journey as we discuss thorny engineering problems with my guests and get into the weeds about how they solve them.
Hey, Suhail, thanks a lot for joining me.
Yeah, thanks for having me.
Maybe we can start off by you telling everybody what you're working on at Playground.
Yes, so I work on Playground, and our goal is to help people make graphics like a pro without being one. So we train a large image model so that we can help humanity do anything they want with graphics. I try not to use the word AI too much, but I think like there's a whole bunch of people that know how to use Photoshop or Illustrator or Lightroom, and they've become used to those tools and they've become experts. And then there's a whole swath of humanity that like literally has no idea and certainly doesn't have time to do tutorials on YouTube. So what if they could use a piece of technology that could do all of the graphics for them, whether that's making art for your song, or maybe you want to add something to a photo or edit it, or maybe you just want a logo for your company or your startup.
Yeah, so it's less about talking about AI and more about just like enabling people to do the kind of graphic design work that was previously the domain of experts.
Exactly. Our goal, hopefully this year, will be to make sort of a graphics assistant that you could think of it as your graphics artist or your graphics designer. You could talk to it and ask it to do certain things, and you can iterate or collaborate with it, but you don't need to have any of those skills. You could think of it yourself as like a marketer or a product manager, or just a founder of a company, and this thing will do all the work for you.
Awesome. Perhaps you could tell us a little bit about your background and how you ended up working on Playground.
Yeah, when I was 20, I applied to Y Combinator and I started this company called Mixpanel, which helped mobile and web apps measure what their users are doing. So, we would help people make a funnel or help them understand, what percentage of users came back. And so I ran that company for about 10 years and then decided to work on something new.
And so there's, probably a lot to the architecture of this technically, but you started off thinking you were going to be able to use off-the-shelf diffusion models as the backbone for the product?
Yeah, small, like the very short history. It wasn't that we had no plan necessarily to make a train or do research for AI. It's just that we weren't sure whether two things can happen when the pace of technology is accelerating so quickly. One thing that could happen is the technology goes very quickly and you can focus on the application. You could just keep making a great product, and other people are working on research, but you can just adopt what they're doing and like make a great application. And then the other version of this is it turns out like actually maybe there's either not a concerted enough focus to making the technology better, or the technology is just not accelerating that fast. In which case, your users are just going to complain that you're just not able to do something that they really want it to. And in that case, you kind of have no choice. And so we weren't really sure at the time whether it was going to be the first idea or the second idea or something in the middle. And so we first just said, okay, let's try to ship something to the world and then we'll find out all the flaws. And there's certainly going to be flaws because we can see them. I think the great thing about images is that you can see all the flaws. Unlike, if you get a big paragraph of text, it's sort of hard to read all of that. And so it just turned out later on that it just wasn't accelerating fast enough.
And was it just the pace that you were going at was the main concern, or were there specific features or functionality that suggested to you needed to be starting to do research yourself?
Yeah, I mean, we kind of just like built all the features that we could build. And then it felt like, and then we kind of found out later that a lot of those features were either one, hard to use, right? So an example of that would be in the image domain, this is still an unsolved problem in the image domain, but one problem is still character consistency. If I were like writing a book or, you know, something like a children's book, I want the same kind of character to go across each page. And just even that remains like a relatively unsolved problem. And the other times, sometimes the problem is kind of solved, but it's just hard to use. And so the average person can't really find value in it the way they hoped. And so both of those things tend to be somewhat true in the domain of images. And it just turns out that this particular modality or thing, unlike text or language, is just so deeply underinvested in. It's like many billions of dollars. Like language has maybe like 20-30 billion dollars going towards it, and like images has like sub 1 billion.
Yeah. And by the time you decided you needed to get into research, did you feel like you had enough like user usage to understand what the next steps are? Like, was the whole time you understood what features you needed, or did you like see how people were using it and then like sort of step back and be like, all right, here's where we need to go?
Fortunately, with images, you can kind of like get both. So, you know, there's obviously the normal things that if you're in the know, like, or if you even kind of use these products or tools, there's kind of the normal things that are like just silly that obviously don't work, right? Like for some reason, text generation is still kind of difficult. For some reason, hands and faces are a little bit garbly. I mean, these are still they're getting better, but they're still like not as solved. And then there's just even more obvious things, like these things are very hard to control. There's not a lot of flexibility. What if I want the same character with different lighting? How do I like edit these things? Like editing is still not a capability. And so when you think about language, the language models are capable of like thousands of tasks, it feels like, right? There's like everything from coding to, you know, getting sometimes just like uploading your blood test results and seeing what you get. But in the world of images, there's like this simultaneously weird paradox where like on one hand, there are a whole bunch of people that are like, what's left to do with images? You just write text, you get an image, like what's left? And then on the other end, and so that feels like one task and we're done. And on the other end, like we know that the quality, we just look at, if we use any of these models, whether it's DALL-E or Midjourney or whatever, we look at the images and we know that they're actually just super low quality still. Like they're not good enough. And so how can both things be true?
Or there's very visceral examples for this is not what I asked for or not what I want.
Exactly. So it's so clear that, and so the problems to me seem so clear. And so the problems can either be very personal, like I wish that I could make a logo, or I wish I could edit this picture, or I wish I could add someone to this thing, or make my son smile and not frown in the holiday picture. You know, and then there are other things where, you know, your customers are definitely telling you what they want. Like, I definitely get customers that say, I wish that I could use this character or put myself in this and then like have different scenes and stuff. Can I make it? And then there are other people that want things to be kind of like directable. Like I get like right now the image models feel like loot boxes. You know, you type something in and then you get some weird thing out and maybe you want it and maybe you don't. And so people obviously want it to be more directable or steerable. And that's been challenging. Whereas with language, it's less so. You know, you get unwanted things still, like hallucinations, and for some reason it can't add big numbers and things like that. But it's way more directable or steerable, and there's so much effort trying to get it to be almost deterministic. So it just feels like we're so far away in images compared to language.
Yeah. There's also, I mean, it feels like there's an aspect of it. It responds like a human, so you give it some more affordance for talking around things or whatever. So you got to the moment you're like, this isn't good enough. We're gonna have to get into research ourselves. Did you feel like you understood what that entailed? Had you spent enough time in the open source models you were working with to have intuitions around here's how we go build this? Or was it, you know, like what does day zero look like?
Yeah, not at all. I mean, I've been programming for a long time. So over the last 15 years since I started Mixpanel till now, like I certainly spent time like learning about machine learning and like teaching myself. And there was a time where in machine learning, for people that don't have a strong sense of this history, and this is not the entire history, it's just maybe just like the last 20 years, machine learning just kind of for a long time in Silicon Valley had like these fits and starts. Like it seemed like right when deep learning kind of came out, people were really excited. And then like it didn't quite translate into anything that exciting. And so, I definitely got bit with that bug and even started like a machine learning team at Mixpanel to try to like predict, people who would convert through a funnel or which users would retain. And so none of those projects ended up panning out.
Yeah.
So I had like some very vague idea, but it wasn't until I got into it which was really started around maybe like most earnestly January 2022. I think I like made like a live Twitter thread of just like everything that I was learning and posting it because I thought people would be interested watching someone go from kind of not knowing a lot to like trying to figure out how to know a lot more. And I think for the most part, I didn't realize the complexity. I didn't realize how much further things had gotten and how much complexity there was to training these like really big models.
Yeah.
And so you were just reading research papers at first mostly, or?
No, even worse than that. I didn't know how to read a research paper.
Yeah.
I would like look at the research paper and I would look at all the math symbols and I'd cry. I'd be like, oh my God.
Yeah.
You're like, how am I going to overcome this? So I first started with like this like fast AI course by Jeremy Howard. That was the original way that I learned ML, but it had been updated many times. And I remember in that course, Jeremy just kind of describes how you just need to like push through and just keep reading the research papers, even if the first 20 times it's like extremely hard. And that was totally correct advice for me. And so I definitely read like many hundreds of research papers, even though I didn't understand like at first, like I didn't understand 90% of it.
Yeah.
But no, I think the best way that I learn is by doing. So I just started training models, like little models, little baby things, and struggling and failing, and then I was strange. I think I knew that probably the way to learn quickly was probably not just struggling, but so I kind of put a call out on Twitter to find like an AI mentor and exchange whatever startup advice people would want for AI mentorship. So a bunch of people DM'd me, but one person in particular was this guy named Igor Babushkin. And and the funny thing about Igor is that I didn't quite know everything that he had done previously, but this guy, he actually leads the XAI team at Elon's thing.
Yeah.
And anyway, so I would struggle. Igor and I would hang out for 2 hours on a Sunday while I was just like struggling, figuring out how to do tensor math with PyTorch. Probably didn't use that mentorship as wisely as I could have because he was teaching me such basic things. But yeah, that's kind of where I started.
And I guess what's something that's kind of struck me as someone is programmed a lot but not gotten deep into machine learning is there's something of a different mentality to it because it's so much less deterministic. I mean, it's kind of like my sense is like there's like a lot of intuition and lore around. There's not a right answer for how you architect a model. You kind of you start to just learn like how to tweak it in a way that might work and experiment.
Yeah, this kind of eluded me for a long time, and to some degree it still eludes me, but there was definitely a time where you're just sort of like, how, like when you come up with this like architecture or a model and you're coming up with these like numbers for the number of layers and how deep the network is and all these various hyperparameters, you sort of like, where did this come, like where do these magic numbers come from? Whereas when you write code, the numbers should almost never be magic, right? You don't even like it's like frowned upon to write them in code as a number that is magic. You like write a constant with the right name and then it has a number to it. But in research, you're sort of like, where is this all coming from? How do people know what to do here? And I think for the first year of the company, like it just continued to elude me, and it's now I've now come to the conclusion that the reason why they're actually not so magical. It just turns out that the way that people derive these numbers to some degree is a combination of their experience. Like they trained a similar model at a different company, and the numbers that they chose worked and got a model that succeeded and had good performance. Or and they're not just two ways, but these are maybe the two most obvious ways. Or they read lots of research papers, and lots of research papers, sort of chose that learning rate, or chose that depth, or chose the number of, the dimension width or something. And so because it's a bit of like trial and error science, You want to start out with something that you know will work, which you can then like tweak from after that.
Yeah. Yeah, that makes sense. Because before you have the intuitions, you could be so far off that it's just discouraging.
Right. I mean, if you're an order of magnitude off on like, let's say something as simple as like your learning rate, then yeah, you might have a model that never converges. In fact, it diverges so significantly. And then you just sort of sit there feeling like you don't know what you're doing because there's too many things that could change. You could change, and you leave feeling very frustrated. And not to mention, you're also wasting a lot of your time in compute.
Yeah. And so what was the context? How big was the team when you decided to start training a model or learning how to do it? Or, I mean, were you basically the lead on it, or like?
We actually didn't really start training until about maybe, I want to say 9 or 10 months like later. I think that, the first thing that happened was we sort of formed this team, and then we started to train like two people started to train a model to try to do like image editing basically. And so we were kind of all working together, and they were doing most of the work. I was doing not as much work, but sort of like watching from the sidelines a little bit, and studying a lot, and maybe probably working on something else. And that model, like we kind of worked on that for 4 months, and it just like got nowhere. You should start your models out very small and like overfit to your data. And there's this amazing blog post by Andre Kaparthi about, I think it's called like The Recipe. And if you just read it, it's like this amazing way to like train your model, no matter how junior or senior you are. All the lessons like still are extremely valuable. But once we failed, we realized that we probably needed people with more experience than us. So that began this kind of big hunt to find really senior researchers who had more experience and more intuition than we had.
Awesome. And then so you were able to hire people, and that's when you started on 2.0, or like what model?
Yeah, so we hired someone out of NVIDIA who had worked there for 5 years, did research on 3D and GANs, and he brought a level of experience that I think our team just like really needed at the time. And so that began kind of our first. So we basically kind of decided to not train anything really big. We were trying to do like some small scale stuff and kind of like learn. And so I think we had set like this very, very unambitious goal actually, to try to just get a model that was as good as Stable Diffusion 1.1, right? And we were just like, if we could just reproduce that would maybe tell us that, that we'll learn a whole bunch of lessons from there. And maybe, and there's a whole bunch of stuff we need to build on our way there anyway, and to beating that anyway. So we sort of set out, the first goal was just to do that. And we trained that, and we focused on hiring, and then we found someone, and then we kind of like trained that model, and like we ended up finding out that we had like overshot it. Like when training was done and we evaluated it, it was actually like basically as good as like Stable Diffusion 1.5. So we were kind of like, oh, okay, that wasn't so hard. That wasn't so bad. Yeah.
What profile did you go looking for? Was it just image research generally, or someone specific to diffusion models?
We were definitely looking for someone that had done stuff, like had done, computer vision specifically. Yeah. And had done things particularly with images. Yeah. But we were not super biased on whether they had done like diffusion or not.
What was the approach to like, all right, that this worked, like we should keep doing this, and then you started training 2.5?
Yeah, so I think when we hit that goal, we decided, okay, we should try to pick like a slightly more ambitious goal. Like maybe this wasn't so hard. So we were like, okay, let's just try to beat. Let's try to, instead of trying to get to, since we overshot the goal, let's try to get to like reproducing like the next model after this one that was already out, which was Stable Diffusion XL. It was a bigger model, slightly different architecture, that sort of thing. So we embarked on that, and our only goal was to like basically match it quickly, but match it. And then the same thing kind of happened. We like not only did we reproduce it, but we like overshot it again. And so we released that, I think like December of 2023, and we called it Playground V2.
All right. And then what, like, were there core like learnings or unlocks, or was it just kind of more of the same iteration in terms of like, what does it feel like if you had to explain to someone like the process of like going from this model that works at one level and being like, I think we can do better? Like, what are you thinking about?
Yeah, sometimes I feel like training models is like the closest thing that people in software can get to like the feeling of trying to like launch a rocket or something, because when you run these training runs, like they're very expensive. So
Yeah.
if you're not getting things right, you're wasting a huge amount of money, no different than like launching something. And you can do various tests along the way, but like it might blow up or it might not get you to the end result, right? And back in January earlier that year, we had worked on all these things for 4 months and then didn't go anywhere. It basically blew up on the launch pad. We never get that time and money back, but you learn some things when you do that. So that would be like maybe one small analogy. But I think when we kept trying to train increasingly larger scale models, which also required more compute, required more data, required more of an effort. There's just like so much plumbing and complexity that goes with this. Like, maybe training a 1 billion parameter model, maybe you only need like, 32, A100s or 64 or something small or 128. But then maybe going to like, 2 or 3 billion, now you need like, there's just more complexity, more things can go down, more things could fail. And so, but the nice thing is by doing it, starting small and kind of growing, we didn't have to deal with all that complexity at the same time. So, so we kind of like we had more people, we had had our data sets, we kind of had a sense of, we could always go back if we needed to, and we would know we could fix our bugs. We could always start from a baseline state where we knew it would kind of work. And so, so we just kind of did the same formula again.
Yeah.
And of course, we had bugs and failures and all kinds of things. And I think there was like probably a month where there was like training would fail like every single day somehow, and you just have to like fight through those problems. Not that different than like scaling a website.
Yeah, that's what it's sounding like. It's like the same fundamental technique, but kind of scaling in the traditional sense of just more infrastructure to allow it to work on more computers at the same time.
Yeah, exactly. So that was really what it was like to go to do that. And then I think what happened after that model in December, I think the team felt like we had like barely done all the things we could do to make the model better. Like our goal was like, once again, like very unambitious, like not ambitious enough. We thought it was because we had never done it before. Ambitious for ourselves, not for humanity. Like reproducing something is like whatever. But I think that when the team kind of reached that, I think that the next goal was like, well, it seems like it would be very easy to just like completely beat this by like a much wider margin.
Yeah.
So why not just let's just try it for like 2 months. Like just work on this thing for 2 months, and we have some very clear ideas on how we would do that. And we had read a whole bunch of like different research papers and kind of glued together some of those concepts. And so then that was what we launched in like this February. It was Playground 2.5, which like completely crushed whatever the current, like literally every open source model that was out there for image gen. And so that felt like but again, I think we were only looking for like maybe like a 2x leap or something like that. And it ended up being like a 4x leap. So even then we still kind of came to the same conclusion that we're like, oh, we still overshot where we thought we were going to be. Maybe our goals are still really crappy actually.
Yeah, that's interesting. I mean, it kind of feels like it mirrors a thing I've noticed in programming generally, where some domains seem almost unattainably complex until you just start doing them, and then you gain momentum, but also like confidence along the way of like, oh, that wasn't so bad. Like, why can't I do more of that? How did you figure out like how much bigger to go? Like, is that a hard problem to think through? Like, like we're at one level of resource usage on this model. It seems like it's going to keep working if we add more resources, but they're costly. So like, how do you figure out how aggressive to be?
Yeah, that's a question that we've been kind of like trying to answer for ourselves somewhat with our next generation model. For the last model in February, we didn't increase the parameter amount at all. So we knew that it would converge, but we just felt like the people that had trained, all the people that had basically trained that architecture of model and that at that capacity had not pushed that architecture far enough, and it seemed very achievable to us. So what we put out was a paper that was like, look how far you can go with the same architecture. This next generation model, practically everything is changing. This time around, we're trying to have a level of ambition for the model that hopefully we undershoot it. Hopefully we actually undershoot it. And that will tell me that we kind of picked the right set of goals. I think, again, it's kind of tricky. You need people on your team. And since then, we've hired a lot of great people onto the team. I think you need people that have a level of like confidence and experience to know that they could train that model at that scale or that capacity. They have to have like a core belief, and some of their core belief is experience, and some of that core belief is like written in the literature. I think the largest like vision transformer model, for example, was trained like that. There was like a blog post from Google, and it was like 22 billion parameters. And there's a whole bunch of papers that try to like scale transformers versus like convnets from Google as well. And so you just like look at the literature and you go, how possible is this? And so it's actually so with language, there's so much literature about people trying to scale things in the hundreds of billions of parameters at the very least. And that's almost like a small model.
Yeah.
But for images, there's not a lot of literature about like someone trying to scale something to, 100 billion parameters. So it's kind of this new frontier, actually. We don't know. We don't know how far it can go, actually. And to some degree, we have to try. We have to test.
Yeah, that's interesting. It feels like it ties heavily back to your analogy to hard tech or space, where it's for a while you could have confidence in that the architecture worked and you could keep scaling that up. But now you just have to have confidence in the team and the breadth of things you've seen and their intuitions for how it's going to keep working because all the things they've accomplished in the past.
That's right. Yeah, I think that's totally right. I mean, I think I was talking to some founder of like an asteroid mining company, and like, I don't know, there's not that many people that have built, I don't know if anyone has built anything that does asteroid mining yet, but I'll assume that someone has.
Yeah.
I mean, there's just like how many people have tried. So I think, the way I used to characterize it with my team was, I was like, we're not really wandering around in the darkness. Like we kind of know like the path. We have like flashlights and machetes, and we know where we're going. And the reason why we know where we're going is because we can literally see the path that someone else took. So it's not that hard. It's tough, but not hard, because it's only tough because we don't know what we're doing. But I think that at some point, we're now kind of hitting the point where like there's not a lot that we can read that we don't know. And so now we're mostly wandering in the dark, trying to forge like whatever the next path is.
Yeah, that's interesting. We are investors in an asteroid mining company, and I think a big part of what they talk about is when they go tell people about it, it's like no one has done this task, but there's like if you walk someone experienced through the constituent assumptions of the individual subtasks, like they make sense, and so there's no reason you can't put those together.
Yeah, I think that's right. I think it's the same thing, but and we are much more experienced now because we blew up, and then we like blew up our training run back in January or last year, and then got like small wins along the way. And so we kind of have a sense, we know how to not accidentally spend too many millions of dollars worth of compute on something that's not going to work also. Yeah,
that's interesting. What are you paying attention to in AI broadly? Are you pretty focused on what you guys are working on, or do you have like a lot of like strong opinions about what else is going to happen in the ecosystem?
I think like one broad feeling that I think a bunch of people had maybe early last year was that the models seem like a lot of the models are just like text in, text out, or text in, image out. And these models are like extraordinary at extrapolating. And so these like multimodal models will be very fascinating. And so anyway, there's just this significant complexity to training those models because, now you have to have like an audio, text, and image, or video, or 3D, or like any of these things. Like it becomes like this very huge, difficult model, complex model to train. And they might be more complex than shooting rockets into space. On like some level. They might be.
Yeah. And so how do you think about how you continue to build models, and if that sort of, is there going to be convergence on multimodal models, or is just focusing on the tasks that your users need to get done?
Yeah, we're extremely focused on images. We're very focused on images because I think it's tough for me to say, hey, we should like expand the set of modalities that we should encompass in this model when the task itself feels so low quality and broken and incapable, So I think that we're very focused on images, but I think our overall plan is we really want to make like a vision first model. It feels like most of the world is so focused on language and text, but there's this like under investment and appreciation for what would it be like if you made like a very great unified large vision model. where vision was your priority.
Yeah.
And it's somewhat unclear whether like the all out models are like going to get the best results unless you have like a large enough investment and a large enough team that deeply cares about each one of those modalities, which is certainly possible at the scale of like Meta or something like that.
Yeah.
But these companies have different corporate interests as well, right?
Yeah. And then, I mean, the multimodal things you kind of get, it ends up more diffuse in terms of precision for specific use cases, whereas you have a bunch of precise use cases that your users want that are very obviously lacking today that you want to deliver on.
Yeah, I mean, just give you like one example of like something we care about, but I don't know if like people care about other institutions. And I don't think it's like a big secret because you'd have to like, there's 100 of these things that we care about. Like, yeah, you know, I woke up on Monday thinking about color grading in images. I'm just like, you know, there are these images and it's got these like different dual tones and monotones. And like, if you look at cinematic imagery, they have excellent color grading. And if you don't know what color grading is, I mean, just think of like a movie like Mad Max where it's like orange and pastel blues and like dusty. The color grading of that film is like very specific. And I think about that every day, that kind of stuff.
Yeah.
But I don't know how many researchers at, you know, OpenAI or Meta or whatever are really thinking about color grading.
Yeah. Yeah.
They're probably thinking like, oh, I need to figure out how to get text to not have like 2 O's in it or something, which I also care about.
Yeah, totally.
But that's not that. But I there are like so many dimensions to images.
Yeah.
And anything, you know, you pick any discipline in the world, whether it's audio or whatever, there's going to be a set of people that just deeply care about that.
Because you want a product that both lets people who aren't experts in the domain do professional results, but also meets the needs of professionals who are used to all these dials they can tweak.
Yeah, whether your product is meant for professionals or not, like certainly we want a product that professionals would think is good. One thing that is true in research land is that researchers love to beat other researchers. It's competitive in like sometimes mostly in a good way, I think.
Yeah.
Right. But the problem is there's an incrementality to that where it's just my only goal is to beat the next researcher or the next best thing, right? How do I get a slightly higher MMLU number, right? We see all these Gemini posts and we're just you go and look at these benchmarks. I mean, they're kind of like, a lot of them are kind of crappy, right? What we try to strive for is perfection. And that might sound, I don't know if that sounds trite, but like we don't go, is our image better than, you know, Dolly or something? We say, is our image as good as the most perfect thing that someone could take with like a camera or draw or, you know, illustrate in Illustrator? That's like the hardest eval that you could produce. And that kind of thing makes you look at the details of what you're making and what you're referencing. You will notice the tiniest thing that feels off. But it also make very noticeable things like color grading make you want to fix them.
Yeah. Would you say that relative to Mixpanel or even Mighty, like this process has taught you anything about engineering or organizing an engineering team?
Yeah, I mean, I didn't really know how to organize a research team, and I might still not know how to organize a research team because it's not like our research team is hundreds of people or anything. It's very small, actually. So, but I can tell that organizing research is not the same as organizing a software engineering team pushing out features, you know, every week or two. You wouldn't like really ask your engineers to just like sort of wander.
Yeah.
Right. There's, to take my forest analogy, like if you're wandering in the dark in the forest, you need some people kind of wandering in different directions for a short while to find out if that's the right path. And I think with research, you have to have some bandwidth to allow very smart people to wander. And so the kinds of people you need for research have to be people that don't always need your guidance. Like they need to be giving you a lot of the guidance. They need to bring a level of, I don't know, like a level of intuition and like persevere. They need to have like some sense of persevering through these like hard problems, like, because it's very easy to get stuck with research and there's not an obvious clear solution. So I think running a research team is very tricky, very hard.
Yeah, and organizing it because it's both this scientific method process where any individual experiment may fail, but it's also very expensive. So the resource allocation problem is interesting in its own right.
Yeah, and I don't mean to make it sound like, you know, running research teams is a new thing, but I think in the world of where we are with AI, there's not that much wisdom yet in terms of like running research teams in a company that's meant to create products for humanity. Like there's definitely people running research teams at academic institutions, but those goals are completely different than a company who has to deliver to customers.
Yeah.
And how do you balance like the timeline of what you ship and whether it's good enough? You know, there's even with research, there's this idea that there's what's possible, but it doesn't necessarily mean that it's good enough.
Mm-hmm.
And so with product, you can usually go, well, I want the pixels to be perfect and I want there to be an animation and it has to be fast enough. And so there are kind of these clear requirements. And, you know, but with research, you might not get a model that's high quality enough. And so people are like, well, I can't use this. It's not good enough.
You're kind of merging two domains in the end. What can you tell us about what we should look forward to from Playground?
I think that people should look forward to being surprised about what maybe, I guess the thing I would say is like, I think that people should expect that images are going to go much further than they have been. I hope we show that to people this year. I hope it's not just like, oh gosh, like the hands are still off and still has like weird text generation, and those feel like simple problems that these models have to solve. And I think what these models haven't shown is this kind of like thing where they can like accomplish hundreds of tasks. Mm-hmm. We haven't really, in my opinion, I feel like these models are not even like GPT-3 level class.
So the process so far has not daunted your ambition. Do you feel good about the end state?
I feel like we have so many ideas,
mm-hmm.
and it's just maybe perhaps the most surprising thing to me is that they feel so unpursued.
Yeah,
I don't feel like we're at any point of feeling stuck. If anything, it feels very clear to us anyway that so much of what we do with graphics can be approximated. There are so many patterns actually with graphics. Like, why can't these models do great? It's like somewhat disappointing if you use them, but you can't do anything to improve them. But it's extremely exciting if you get to make them better. You sort of look at how like little we've done. So maybe it just feels like opportunity mostly.
That is exciting. I look forward to trying it out. Well, thanks a lot for joining me today. It's been really fascinating. I appreciate you coming by.
Yeah, thank you.
That's it for this episode with Suhail Doshi, founder of Playground AI. On the next episode of HiBit, we sit down with Vince Chu, co-founder and CTO of HomeVision, a startup providing comprehensive collateral underwriting powered by machine intelligence. HiBit is produced by Initialized Capital. Our showrunner is Candy Chang. Our videographer and editor is Kevin Heintz. And I'm Brett Gibson. Thanks for listening.